So you've probably heard the word blockchain, right? It's everywhere, usually tied to crypto or the next big thing in tech. But what if I told you it's real power? It's real magic, isn't about money at all. It's about trust. Today, we're going to strip away all that hype and get right down to the nuts and bolts of a technology that's fundamentally changing how we record, well, pretty much everything. All right, to really get what blockchain is, first we have to understand the problem it's trying to solve. Think about how we usually store important information. It's in a traditional database, right? Basically, one single guarded master copy. Now, if that one copy gets hacked or corrupted or just goes offline, you're in big trouble. Blockchain flips that on its head. Instead of one guarded copy, it uses a distributed ledger. Imagine thousands of identical copies of the same notebook, shared with everyone in a network. There's no single person in charge, and everybody holds the same version of the truth. It's a total game changer.
Okay, so here's how we're going to break it all down. First, we'll look at this idea of a new kind of ledger. Then we'll dissect the blocks themselves, Anatomy 101. After that, we'll get into the unbreakable digital seal that keeps them safe. Then we'll see how those blocks forge the unbreakable chain. And finally, we'll see the security domino effect that makes this whole thing so powerful.
All right, let's jump right into part one, a new kind of ledger. Before we can talk about the chain, we got to understand the book it's written in. So, what is this core idea of a distributed digital ledger?
So, when you boil it all down, what is a blockchain? Well, the simplest way to think about it is as a shared digital notebook. But this isn't just any old notebook. It has some superpowers. First, once you write something in it, it can never be erased. That's what we mean by immutable. And second, it's distributed, which just means everyone in the network gets their own identical copy. This makes it an amazing tool for recording transactions or tracking pretty much any kind of asset.
And these key features are really what give blockchain all its power. Shared means total transparency. Everyone sees the same thing. Immutable means the past is literally set in stone. You can't go back and change the story. And distributed is huge. It means there's no central weak spot for an attacker to target. And remember, we're not just talking about money here. You can use this to track anything of value, tangible or not. Think house deeds, company stock, even digital art.
Okay, so we've got the big picture. But the name is blockchain, right? So let's zoom in on the first part of that name and look at the anatomy of the blocks themselves. These are the basic building blocks of the entire system.
So, what is a block? The best analogy is to just think of it as a single page in that digital ledger we were talking about. It's basically just a container, a page, that holds a list of all the most recent transactions that have been confirmed.
So what exactly gets written on one of these pages? Well, it's three really important pieces of information. First, you've got the transaction data itself, the who, what, and when of it all. Second, there's a super precise timestamp marking the exact moment the block was created. And third, and this is key, it has a cryptographic hash. You can just think of that as the block's unique, unforgeable ID.
Okay, that third item, the cryptographic hash. This is where the magic really starts to happen. Let's dive into that. This is the unbreakable digital seal that makes the whole system work.
So what in the world is a cryptographic hash? The easiest way to think of it is as a unique digital fingerprint for any piece of data. There's this cool mathematical algorithm that takes all the info inside a block, crunches it down, and spits out a unique string of letters and numbers. And that string, that fingerprint, is one of a kind for that specific data. Check this out. You take a piece of data, like a transaction saying Alice sends Bob 10 BTC. You run it through the algorithm, and boom, out comes this unique hash. And when I say unique, I mean it. It's basically impossible for any other piece of data in the entire universe to produce that exact same fingerprint. It's a perfect digital ID.
But here's where it gets really clever. Watch what happens if we make the tiniest, most insignificant change to the original data. I mean, we're just changing 10 to 1.0, a single decimal point.
The hash becomes completely and totally different. It's unrecognizable. This is called the Avalanche effect, and it's the core of blockchain security. A tiny, tiny change in the input creates a massive, unpredictable change in the output. This means that any attempt to secretly alter the data is, well, it's not secret at all. It's instantly obvious to the entire network.
Okay, so now we have these perfectly sealed, tamper-evident pages, or blocks. The next logical step, right? How do we connect them together to forge that unbreakable chain we keep talking about?
And it all hinges on one simple but absolutely brilliant rule. Every new block that gets added to the chain doesn't just have its own unique hash. It also includes the hash of the block that came right before it.
And you can see exactly how that works right here. Take a look at block 2. See how it contains the hash from block 1? Now look at block 3. It contains the hash from block 2. This creates this incredibly strong cryptographic link, literally chaining each block to the one that came before it, creating a continuous chain all the way back to the very first one, which we call the Genesis block.
All right, now we can put all these pieces together. We have the blocks, we have the hashes, we have the chain. Let's see how this creates the Security Domino Effect, and why everyone says it's nearly impossible to alter a blockchain.
So let's play this out. Let's run a little thought experiment. What happens if some bad actor, an attacker, tries to cheat? What if they try to go back in time and alter a transaction that's already been recorded on the chain?
Well, let's say our attacker messes with the data in block 2. Instantly, because of the Avalanche effect, the hash for block 2 completely changes. But here's the problem for them. Block 3 is still holding on to the original hash from block 2. All of a sudden, chain doesn't link up anymore. The connection is broken, and it's a huge red flag for the entire network.
So, to hide their change, the attacker has an impossible task ahead of them. First, they have to recalculate the new hash for their faked block 2. Then they have to take that new hash and update block 3. But wait, that changes block 3, so now they have to recalculate the hash for that one. Then they have to update block 4, and so on for every single block that came after. And here's the real kicker. They have to do all of that, this massive amount of work, faster than the thousands of other computers on the network can add the next real block. It's a race against the entire world, and it's a race they just can't win.
There's a great saying that really captures this. The security of the past is constantly being reinforced by the present. Think about that. Every new block that gets added makes the entire chain that came before it even more secure. So the longer the blockchain gets, the more impossible it becomes to change the past. It's an incredible, emergent form of security.
So when you step back and look at the whole picture, the real innovation here isn't just the blocks or the fancy cryptography. It's what it all adds up to. A shared, verifiable, and basically tamper-proof source of truth. It's a way for us to trust a record without having to trust a central authority like a bank or a government. And that leaves us with a really big question to think about. If you can create a foundation of unbreakable trust, what could we build on top of it?